chapter, we were solving lots of triangles, finding angles and finding sides, but we were using SOHCAHTOA to do that. Because every time, I mean, think of it, we got the squirrel on the top of the tree, right? We got the flagpole. We had a right angle in every one of our problems. So SOHCAHTOA, the Pythagorean theorem, those were wonderful, wonderful tools. We are today going to look at triangles that aren't right triangles. Okay, so I've drawn one up here on the board. And just to refresh your memory, when we draw a triangle, we can call the angles whatever we want with capital letters. I call these A, B, and C because that's what I got on the sheet there. But the sides are always labeled with small letters then across from their angles. This is going to be crucial as we progress through this unit. So make sure that when you set your triangle up, I don't care where you put A, B, and C. Big A, B, C, doesn't matter. But once you get your angles labeled, then the sides have to be labeled accordingly. You see what I'm saying? Okay. Now, we're going to derive the law of sines. It's not something that's just made up. We're going to derive it. So I'm going to drop an altitude in this triangle. Remember what an altitude is, a perpendicular from a vertex. This triangle is not special in any way. So these two pieces aren't equal to each other, right? But now I do have two right triangles. Would you agree with that? So in this right triangle, it's a right triangle, this guy right here. I'm going to say sine A equals H over C. Now I'm only looking at this right triangle right here. That's true. We actually used this concept back, we had a problem where there was a balloon up in the air and two guys were looking at it. You remember, or something like that? You don't? Okay, just block that out. Anyhow, we had a situation like this, and we had to figure out how high the balloon was off the ground. So we split it and did two triangles separately. So sine A equals H over C, and what does sine C equal over here in this right triangle? H over A. Now, both of these equations have an H. So I'm going to go ahead and get the H's by themselves. So H equals C sine A, and H equals A sine C. Would you agree with that? Well, now, since they're both H's, I can set them equal to each other. So C sine A equals A sine C. And now I'm going to break one of the big rules that I just yelled and lectured at you about last time we were together. I'm going to divide both sides by A and C. Now, why is it that after making such a big deal with you guys about don't divide by a variable, why is it that I think I'm allowed to divide, Hank?
Because you can't really have a zero for A.
A and C are sides of the triangle, and so I am guaranteed that they won't be zero. Exactly. Well, what happens when I do that? Well, the C's cancel with sine A over A, and the A's cancel, and I'm left with sine C over C. This is the law of sines. The law of sines tells us that the ratio of the sine of an angle to its side is the same for every angle and side in the triangle. Now, I happen to draw this altitude. Could I have drawn this altitude? Yes, and then I would have had the same kind of work, but it would have tied together angle B and angle C. Right? So I'm going to go ahead and just tack on sine B over B. This is the law of sines. It works in every single triangle. It's true in every single triangle. I shouldn't say it works. It's true in every single triangle, even right triangles. You can use the law of sines instead of SOHCAHTOA if you wish. All right, let's do an example. solve triangle ABC given this information. All right, so here we go. We have triangle ABC. Again, put ABC wherever you want. But if I put A here, then I have to put side A over here. B is 48. And I guess that's all I know. So solve the triangle means find everything that's missing. So I need to find angle C, I need to find side C, and I need to find side B. That's what I need to find. Well, one of those is easy. Which one of those blue things is easy to find?
Angle C.
Oh, yeah, because the angles of a triangle have to add up to 180. Yeah, so we don't need pre-calculus to do that. So it's 96. Now, what about the sides now? I have to find the sides. So it's not a right triangle, so I guess I'm gonna have to use my law of sines, which I erased, but it's easy to remember, and it's on your colored sheet. So the law of sines would say sine 36 over 8. This pair right here is kind of the starting point. So sine 36 over 8 equals sine 48 over b. Could I also say sine 96 over c? Yeah, I have to do both of them, and the order I do them doesn't matter. So I just went alphabetically. All right, this is a proportion. How do we solve a proportion? So b sine 36 equals 8 sine 48. And b equals, I'm going to divide by sine 36 because my goal is to solve for b. So 8 sine 48 over sine 36. Now I gotta have the rest of this chapter, we have to have a calculator every single day because that's what we have to figure out. When you type this in, please make sure you remember to close the parentheses after the 48. So you're gonna hit 8 sine 48, close the parentheses, and then divide it by sine 36. I got 10.11. Did anybody else? Is that okay? Everybody good on that? So now we're going to turn around. This is so easy. We're going to turn around and we're going to do exactly the same thing, finding side C. So I'll say sine 36 over 8 equals sine 96 over C. I'll cross multiply and divide. Anybody have a question about what I'm doing? Is everybody following along here? So 8 sine 96, close parentheses, divided by sine 36. I got 13.54 for that one. And the triangle solved, and we're done. Probably good. One of the easiest things we're going to do all year. Right? That's simple. Well, quick observation. Do the lengths of these sides kind of make sense? I mean, does it make sense that 8 would be the smallest side? I mean, this would be the smallest side, and this is the medium side, and this is the biggest side? Yeah, why? Because that's the order of the angles. And the bigger the angle, the bigger the side, right? So keep that in mind, because it's possible things might get waffle jawed. All right, let's look at the next one. Same thing. triangle ABC. Side A is 7, side B is 6, and angle A is 26.3. Now this one is going to be a law of signs problem, but there's a little bit of a difference. Do you see what it is? When I set up my law of signs, right here's that pair that I like to have. So sine 26.3 over 7. And what am I going to set that equal to now? Sine b over 6. You see the difference, kids? So my variable now is sine b. So I'm going to multiply by 6. How do I type this into my calculator?
Inverse sine.
Exactly. Guys, this is not separable. You cannot separate these two unless you inverse sine. That is the only way to find that angle. You're going to have to inverse sine this big fraction. No big deal, your calculator will do it. Second sine, 6 sine 26.3, close parentheses, divided by 7. Did you get 22.32? Is that what you got? All right, where do we go from here? Yeah, now we need to find, oh, now can we find angle C now? Yeah, because we got the other two. So 180 minus 26.3, oops, 180 minus 26.3 and 22.32, 131.38. How will I find side C then? I love Seth. Is there anyone else who's awake today?
Sine 26.3 over 7.
Sine 26.3 over 7, beautiful.
And then set equal to sine 131.38 over C.
Beautiful, 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 beautiful. Is everybody okay with that? Beautiful, it's great. So now we'll do our cross multiply again. And we have 7 sine 131.38 over sine 26.3. Now, do I need to do any second sine or anything like that with this one? No, that's only when I'm finding an angle. So 7 sine 131.38, close parentheses, divided by sine 26.3. I got 11.85. Confirm? Boy, I'm feeling really good about that, but now I'm just going to throw a wrench in it all. You knew it was too easy, right? I mean, you knew there had to be something. And here's the something. Our first example, our first one that we did, the given information was here, here, and here. Back in geometry, you called that angle, angle, side. That was the given information. Angle, angle, side. And angle, angle, side was a congruence postulate. Remember, you could put it here in your reasons. You could put angle, angle, side. Perfect. As long as you have a congruence postulate, you have no issues. I want you to look at what was given in this problem. The given in this problem was the 26.3, the 6 and the 7. What's that? Angle, side, side. And what do you remember about that? Bad word, can't use it in your proof, right? Now, we just solved the triangle. The triangle, this triangle exists. But when you have angle, side, side, and your clue is right here in step 1, when you do the law of sines to solve for an angle, your little alert radar need to go up. Because there could potentially be another triangle. Angle, side, side is called the ambiguous case. It isn't a congruence postulate, it's ambiguous. What does ambiguous mean? We don't know what we've got. So when you are given angle, side, side, you might have no triangle at all, you might have one triangle, or you might have two. Now, we already solved this one, so I know there's one at least. So now I'm going to show you how to find the second one, or how to check for the second one. Oh yeah, we might have to do the whole problem over again if there's a second triangle. So let me show you how that works. If there is a second triangle, the given information will be the same. So if there is a second triangle, that's given. That's not changing. But back here at this step, when you said B is the angle whose sine is whatever number that is, and it came out to be 22.32, basically what you did is what we've been doing with triangles. You said there's an angle out there, and you found it to be 22.32. But this is a positive number. The sign can also be positive over here. Your calculator won't give you that one. However, you can find it by doing what? How would you find that second quadrant angle? 180 minus. So we're just going to take 180 minus the first one. 180 minus the first one. And we get this is angle B, we get 157.68. Now, sometimes that works, and sometimes it doesn't. Is that triangle possible? Can you have a 157 and a 26 in the same triangle? No. So this is it. There is one triangle possible, and you've already solved it, and all is well. If this had come out to be, let's say, 117.68, that would be possible, right? And so you would do the law of sines now all over again using that scenario.
Would you also just keep doing it over and over if there's only two?
The maximum is 2. The maximum is 2. Because if you moved into another quadrant, your angle was bigger than 180, and that doesn't make sense. So there's a maximum of 2. Could be none, could be 1, could be 2. We're going to do one more problem, and then there's a set where all we do is determine how many. Okay? Exactly. Your signs are going to be the angles are going to be.
If the book
you cannot determine congruence based on angle, side, side. So this could be two different things. And let's do another one, see if we can make sense of all this.
So if one of the angles is an adds up to 180,
It adds up to more than 180. No, it's one solution. We were checking to see if there's another one. There's that one. That one's fine. That one works. But the other one wouldn't because the second angle is too big. All right, let's try again and see if we can make sense of this. Now, I promise that as we go through this, unless you are really on your toes, you're not going to catch that that's an angle side-side situation. If you don't catch it, you will when you set up your law of signs. Because when you say this right here, that's your clue. Uh-oh, there might be two answers to this problem. There might be two answers to this problem. All right, well, I don't know. Let's see. So sine B equals 7 sine 30 over 6. All right, let's see what happens. 7 sine 30. Oh, I got a second sign, don't I? Shoot, I was getting so excited. You get 35.69. Now we have to finish that triangle, but because there's some confusion, let's go ahead and check to see if we're gonna have to do this problem twice or if once is gonna be enough. Okay, so let me just stop a second. We are not done. We still have to find angle C and side C, right? But before I do that, I'm going to come over here and I'm going to try to figure out if there is another possible answer to the problem. And then I'll finish this one. So, remember, if there is another answer, the second angle B, you already found the first angle B. The second angle B is going to be 180 minus the first one. They are supplementary. So 180 minus that one gives me 144.31. Yep.
So could you just say, like, if the second angle is larger than the first one, then it's going to be 2, since you're subtracting then adding?
Probably,
so if it's
yeah.
smaller, then it won't have another one?
Probably. I've never thought about that, but that's probably true. Is this going to be possible? So guess what? We have to solve both of them. Because 35 is fine, and so is 144. So here we go. Let's finish. Let's do this one first, I guess. It doesn't really matter. What would this angle C be? $114.31. Because he's got to add up to 180. And then I'll do my law of sines and say sine 30 over 6 equals sine 114.31 over 6. Are you following along what I'm doing here? I'm finishing my first triangle, and then I'm going to have to go finish the second one.
You get to get
Yeah, we
finish
get to finish it, that's right. Thank you, Sam.
No
Okay,
problem. So
David,
you just do 180 minus 35, and then you get that other one?
to get that second one, yeah.
Okay.
Yeah, because there's two angles that have the same sine value. One in quadrant 1 and one in quadrant 2, and they're supplementary. So the calculator will give me the quadrant 1, 1, and calculate the quadrant 2, 1, but the quadrant 2, 1 won't always work. All right, so let's see, what are we gonna get for angle C, or I mean side C, side C? 6 sine 114.31 divided by sine 30? I got 10.94. Anybody else get that for the original side C? Okay, Well, the fun never ends. We get to step over here now and do exactly what we just did with those numbers. So that angle C is going to be tiny, 5.69. And then sine 30 over 6 equals sine 5.69 divided by C. Ooh, 1.19. Tell me if that's what you got. So again, if you happen to notice that the given information is angle side to side, then you know what you're in for. If you don't notice that, you know at this point, because as soon as you set up your law of sines and you're finding an angle in step 1, then you know potentially there could be an issue. Okay? Because that only happens in angle side to side.
Is it just convenient, or is there something with like 114 or 144 where there's 30 smaller than
Oh, that's because of the 30 there, I think.
Two of the same size.
Well, I don't know, because these have to add up to 180, these have to add up to 180, and these two are supplements. So there's going to be some kind of relationship in there for sure. Yeah. Okay. All right. Let's have you try now, number 2, you're not solving. So luckily you don't have to do all of this. But for number 2, you're going to figure out how many triangles are possible. No, it's not 1, 2, 3, or 4. It's 0, 1, or 2. So we have seen a problem that had 1, and we've seen a problem that had 2. We haven't encountered a 0 yet. I think this might be 1. Let's see. So to determine it, it's all based on angle B. Angle B is the determiner. So let's figure out what angle B is. Sine 36 over 2 equals sine B over 7. So sine B equals 7 sine 36 over 2. Am I going too fast? Everybody keeping up with that? Arithmetic? And then to find angle B, I'll have to second sign that fraction. What happens when you second sign 7 sine 36 close parentheses divided by 2? You get an error. And that means there's no triangles. When the calculator says, I can't do this, that means it's not possible. If you were to type in just this fraction right here, it would be a number bigger than 1. And can the sign ever be bigger than 1? So that tells you there's no triangle. The reality is that if you actually took sticks and tried to make this triangle, that 2 isn't long enough to reach. So it would look like this. That's why there's no solution. But your calculator tells you that. All right, try the next one. See what you come up with for the next one. 0, 1, or 2. Find angle B. That is the key. Or in this case, it's not angle B, it's angle C, sorry. I used different letters in this one. of two things is gonna happen. You're gonna get an answer or not. Did we get an answer this time? What is it? 60.9? Right? So then you immediately think, okay, the second angle, if there is a second angle, would be 119.1. Can you have an 80, wait, that's two ones. Can you have an 82 and 119 in the same triangle? So that one didn't work, which means how many triangles are possible? Just one. Just the one with the 60. Now, you don't have to solve it, but if you did, you would only have one set of answers. There's only one. All right, try the next one. Remember, when you set up your law of signs and it looks like this, you always want to check for another answer in case there is one. Well, you have to second sign it. The C is second sign that fraction. Remember, you're looking for angle C, so you have to second sign it. And that, I got 33.59. Anybody else get 33.59 from the first one? So then the second option, if there is a second angle, these are supplementary. So the second one would be 146. Can I have a 146 and a 36? Nope, so this one has one possible triangle. And I got none for the last one. Anybody else get none for the last one? Yeah. Because when I typed in, I cross-multiplied and divided, it said sine A equals 18 sine 35 divided by 9. So then I second signed that, and I got error. All right, do you feel somewhat confident in that procedure? I got a couple word problems to do now, and then we'll be done with the law signs. All right, so I took this picture out of the book, and it never prints very well. But basically what we have is two markers on the same side of a canyon, and they're 56 apart. So they're called A and B, and they're 56 apart. And then there's this point on the other side called C. I don't know, what do I know about C? Angle BAC is 72, and angle ABC is 53. Find the distance from C to A. Okay, does that make sense to everybody? Okay, what's our missing angle there? 55, you say? Okay. If it's 55, then I guess I can set up my law of sines. So sine 55 over 56 equals sine 53 over x. Does that make sense to everybody? Now the good news is you're not solving this whole triangle. You are specifically finding just that side. So does it make sense to you that the setup looks like that? So let's cross multiply and divide. No second signing here. No ambiguity. Remember what I told you? It's ambiguous if your variable is sine B or sine X or something, right? It's not. So this is the answer, period. 56 sine 53 divided by sine 55. 54.6 basically. Oh, did I get the wrong answer?
I have some answers.
54.6. Anybody else get that same answer? Okay. Now, the second part of the problem says, find the distance between the two canyon rims. Now, I want you to look at the picture drawn on the paper. Would you agree that that distance would be the perpendicular from point C to the other side? So I need to find this distance right here. I'll call that Y. Now here's the happy news. You can use your law of sines if you want to, because you can say sine 90 over 54.6 equals sine 72 over what? You can also say sine 72 equals y over 54.6 because that's a right triangle right there. So you have options. Either way is going to work fine. Doesn't matter. Sine 90 over 54.6 equals sine 72 over y. What's the sine of 90? You already know. You can type it in. I don't care. But the sine of 90 is 1. Right. So basically this says y equals 54.6 sine 72. You're going to have a calculator for this entire kind of problem, so whatever you type in is fine. I got 51.93. And I should be putting units on this. All right. Here we go. We're not done. We got to do 2 more. We got to get 2 more done. We can do it. No complaints. Don't bother me. All right. We got a flagpole standing on a road that slopes. Oh my goodness, 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 goodness. Find, it is a lot of numbers. Find the height of the flagpole. Now, the wonderful thing is, they drew the picture for me. And this is really all I care about, because my job is to find the height of the flagpole, which they call A. And I know this angle is 105. I know this angle is 28. and I know this distance is 16. Now, you might want to spend a little time with that problem in case the picture isn't provided next time. Make sure you can figure out that picture from the words in the problem. But isn't that really all I need right there? Because I can figure out that that third angle is, thank you, and then sine 28 over 16 equals sine 47 over A. Oh my gosh, I love the law of sines, don't you? So A sine 28 equals 16 sine 47. 16 sine 47 divided by sine 28. 24.93. All right, one more. I gotta finish before any music starts. One more, here we go. No picture this time. Forest Ranger Chris at Ranger Station A sights a fire in the direction 32 degrees east of north. So 32 degrees east of north would look like this. Would you agree with that? So here is Ranger Station A. Here's Chris sitting here at the origin. And here's the fire. Ranger Rick at Ranger Station B, 10 miles due east of A. So 10 miles, due east. 10 miles due east of A. Spots the fire 48 degrees west of north. So 48 degrees west of north. Does that make sense to you, the way I have drawn that picture? Find the distance from each ranger station to the fire. So in other words, this would be the distance from B to F, and this would be the distance from A to F. I don't care what letters you use, it doesn't make any difference. Is that going to be a law of science problem? Of course it is. Till tomorrow when it becomes a law of cosines problem. All right, so 32 from 90, remember this is due east, that's due north, so that's what, 58? And this one is 42. Check my arithmetic, I'm doing that without a calculator. And that makes this one up here 80. Okay? So I don't care which one we find first, it doesn't matter. Sine 80 over 10 equals sine 58 over A. And sine 80 over 10 equals sine 42 over B. I'm not going to make you type that in if you don't want to. You know how to do that. Does that make sense to you, though? That would be the setup for the problems? All right, 5:45, homework due next Tuesday. No, Monday, next Monday. Tomorrow's a school day, so it's due next Monday.